SI units, prefixes for SI units, and dimensional analysis. In this unit, you are going to learn 7 basic standard international units and how to convert one unit, one big unit to small unit or small unit to big unit by using dimensional analysis. Dimensional analysis is very important because this is a method by which you can solve big mathematical questions of chemistry with minimum efforts and minimum errors and minimum time. So from my point of view, dimensional analysis is very, very important method and we must practice it. Units of measurement. Measurement is used for representing any quantitative observation. Quantitative observation means in which the quantities are involved with the help of a number and unit. Without unit, if there is no unit, without unit, that number has no meaning. If I say 20 and I don't place any number here, then this 20 has no meaning. You will say 20 what? So if I say 20 kilogram, now it makes a sense because 20 kilogram means 20 kg of the amount or the mass of the substance is 20 kg. If I say 20 apples, this also has a meaning. It means in counting 20 apples. So a measurement without unit has no meaning. That is the reason you have to be very, very careful with units in your examination. So whenever you are writing a number, you have to ensure that you should write the unit after the number, the correct unit. SI units, the standard international units, these are the fundamental or basic units. There are 7 of them and we have to practice these 7 basic units because rest of the units are derived from these 7 basic units. Like mass, the unit is kilogram, not gram. Many students, they take SI unit of mass as gram. No, it's kilogram. And it is abbreviated as kg. You can see that K is in small letter. So whenever you're talking about mass, it will be represented in kg as SI unit. We have other units also for mass. Length, meter. In length, like the width, the height, the distance, everything falls in the category of length. So they all have this meter as the SI unit. Time, seconds, small s. Temperature, Kelvin, K. You know, temperature, we have other units of temperature, like we have degree Celsius, we have degree Fahrenheit. But can you see that with Kelvin, which is the standard international unit, there is no degree. What is the advantage of taking Kelvin as the SI unit? Because the lowest possible temperature on the earth is 0 Kelvin. The lowest possible temperature is 0 Kelvin on the earth. So it means that we don't have any negative temperature in Kelvin on the earth. So scientists prefer to have Kelvin as the SI unit where they don't have to deal with any negative temperature. Degree Celsius can be in negative. Degree Fahrenheit can also be in negative. But Kelvin can never be in negative. Electric current, the rate of flow of charge per unit time. Its unit is ampere, represented as capital A. Amount of substance, mole, represented as mol. So what is a mole? Just like what is a dozen? You know what is a dozen? What is a dozen? So it's not an SI unit. It doesn't mean 12. So what is a mole? Mole is a very special number, Avogadro's number Na, which is 6.022 times 10 raised to power 23. That is a mole. This number is a very big number, and it is the SI unit of amount of substance. Substances are represented in chemistry in moles. Luminous intensity, it is just the brightness of the light. Sometimes you say that your mobile screen is very bright or dim. I cannot read, it's very dim, light is very less. So that intensity of light, the brightness, the amount of the light which we are receiving, so that intensity of light is measured in candela or CD. The best thing in chemistry, we are not using this unit. So in chemistry, we'll be using rest of the 6 units. Now, as I said, these are the fundamental units. And rest of the units are derived from these fundamental units. Like, for example, velocity. Now, velocity unit is not mentioned here because velocity by definition is distance over time. Distance is measured in meter and time is measured in seconds. So what is the unit of velocity? Meter per second. Meter per second. For example, volume. These are derived units by using these fundamental units. Volume. If I give you a cube is a kind of box in which the length, height, and the width are equal to each other. If this is A, we can say this is the length of the cube, the width of the cube, A, the height of the cube, A. The volume is length times width times height. So length is measured. What is the SI unit of length? Meter. Width, meter. Height, meter. So what is the SI unit of volume? Meter cubed. That is the SI unit of volume. Similarly, area. Area is length multiplied by width. So what is the SI unit of length? Meter. What is the SI unit of width? Meter. So unit of area is meter squared. These are called as derived units. You can derive any unit with the help of these fundamental units. So there are so many other quantities, other measurements we are doing, like you are measuring force, you are measuring pressure. So when we are doing all these other measurements, then according to the definition, according to the formula, and then using these basic SI units, we can derive any other unit. Now let's try to understand how to convert a basic unit by using prefixes into more smaller unit or bigger unit. So let's start with a basic unit. This is very important and you have to practice it because they will not give you these conversions in the examination. So for any physics examination or chemistry examination, these prefixes are very important. They are also called as prefixes of metric system. Metric system is accepted all over the world. And this is done so that we can have a uniform system for measurement. Here is the basic unit. Let's take the basic unit as meter. So I'm taking 1 meter. 1 meter means 10 raised to power 0 meter. I can say that. Now on this side, on the right side, I'll convert that into smaller units. Smaller. And means the measurements which are smaller than 1 meter. And on this side, I'll take bigger units. The measurements which are bigger than 1 meter by using prefixes in front of the meter. Going for smaller units, you divide the first one by a factor of 10. Divide by 10. So it becomes 10 raised to power minus 1 meter, which is called as deci, represented as 1 decimeter. What does it mean? It means that 1 decimeter, deci means 1/10, is 10 raised to power minus 1 meter. If you're good in mathematics, you can understand this also. I can write it like this also, that 1 meter has 10 decimeter. I can say that also. So what is d? D small d represents deci. So this is the prefix. D is the prefix in front of meter. Now you again divide it by 10. It becomes 10 raised to power minus 2 meter. Means 1 over 100. We call it as centi. Centi. And is represented by small c, 1 centimeter. So what can you say? That 1 centimeter is 10 raised to power minus 2 meter, or 1 meter is 10 raised to power 2 centimeters. Centimeter. Now again divide by 10. It becomes 10 raised to power minus 3 meter. Now the prefix is milli. Milli. And is represented as 1 millimeter. So what is 1 millimeter? 1 millimeter is 10 raised to power minus 3 meter, or you can say 1 meter is 10 raised to power 3 millimeters. Then after that we have 10 raised to power. Now till here we were decreasing it by a factor of 10, starting from 1 meter. So you are dividing first by 10, then again by 10, then again by 10. But now you will decrease it by a factor of 1000. Means 10 raised to minus 3 divided by 1000. It will become 10 raised to power minus 6 meter. For that we have a prefix micro. Symbol micro, mu. It's a Greek letter. And 1 micrometer is, meter is the basic unit we have taken here. 1 micrometer is 10 raised to power minus 6 meter, or 1 meter is 10 raised to power 6 micrometer. Which one is bigger unit here? Meter. Meter is bigger because in 1 meter you have so many micrometers. Then we have, now again go by a factor of 1000. 10 raised to power minus 9 meter, which is called as nano. Nano means 9. Symbol is small n meter. And 1 nanometer is 10 raised to power minus 9 meter, or 1 meter is 10 raised to power 9 nanometer. And now you can go on. So every time you divide by 1000 factor now. Every time. And use a prefix to represent that quantity. So here it is 10 raised to power minus 12 meter, which is picometer, pico. So 1 picometer. Now again divide by 1000. This becomes 10 raised to power minus 15 meter, which is called as femto. Femto. So 1 femtometer, small f is the symbol. 1 femtometer is 10 raised to power minus 15 meter. Then you again change it by, decrease it by a factor of 1000. So it becomes 10 raised to power minus 18 meter, which is called as atto. So 1 attometer is 10 raised to the minus 18 meter. And now as we keep discovering more smaller units, we can keep adding more prefixes. Now let's go to the bigger side, bigger units. We are going to follow the same sequence, but here the number is increasing by a factor of 10. Like on the smaller part, it's decreasing by a factor of 10 for first three, then by 1000. But for the bigger unit, it will be increasing by a factor of 10 for first three. Now we go on the left side for bigger units. Sequence will be similar, but here for the first three units, going from here to here, then here to here, first three, they will increase by a factor of 10. Now this is 10 meter, which we are going to say deca. Symbol is dA. So 1 decameter is 10 raised to power 1 meter. Now increase by 10 factor. It becomes 10 raised to power 2 meter. We call it as hecto. Symbol is small h. So 1 hectometer is 10 raised to power 2 meter. Now increase by a factor of 1000. The way here, as you reached up to milli, then the factor has become 1000. Every time you're decreasing it by a factor of 1000. Here you're increasing it by a factor of 1000. So 10 raised to power 3 will become 10 raised to power 6 meter. And we have mega as a prefix, mega. Megameter. Now again increase by a factor of 1000. It becomes 10 raised to power 9 meter, which is called as giga. These giga, mega, they are very widely used in computer also. Megabytes, gigabytes, terabytes. This is gigameter. 1 giga. Symbol is capital G meter. Now again increase by a factor of 1000. This will be 10 raised to power 12 meter. So this is your tera. The prefix is tera. 1 terameter is 10 raised to power 12 meter. Like if you are using in computer, we call it as terabytes. So what's the meaning of terabytes? 1 terabyte is equal to how many bytes? 10 raised to power 12 bytes. Right? Same here. So you can use these prefixes on anything. You should have one basic unit and you can use this prefix on any basic unit. It's not necessary that they have to be used on SI units. Now again increase by 1000. It becomes 10 raised to power 15 meter. And this is called as peta. Symbol is capital P. Now again increase. You can keep going. 10 raised to power 18 meter. This is called as exa. 1 hexameter is 10 raised to power 18 meters. So exa is a prefix for 10 raised to power 18 factor. Peta 15, tera, 12. So this is how you can convert a basic unit into bigger units or into smaller units. Now here is the list of the exponential factors which we need to use to convert one unit into another unit. Like for example, if I give you 100 seconds, I'm asking you to convert this into microseconds. Micro is smaller. See the mu symbol, micro. This you have to practice. You have to do plenty of questions based on it, and this is not difficult. You can easily practice it. This is 10 raised to a minus 6. So what do you know? You know that 10 raised to power minus 6 seconds is 1 microsecond. Now you can use dimensional. Start with this 100 seconds. 100 seconds. Use this ratio. What do you want? You want microsecond. Plug in this microsecond in the numerator here in the numerator. Plug in this second in the denominator. Can you see seconds and second cancelled? So what's the answer? 100 times 10 raised to power 6 microsecond, which you can write like this. 1.0 times 10 raised to power, this is 6 and this is 10 raised to power 2, 8 microseconds. That's the dimensional analysis. You can use the ratio to convert. This is something which is, I'm calling it as a ratio. I know this ratio. So I'll plug in this ratio in such a manner that seconds and seconds cancelled because I want my answer in microsecond. So you should have your microsecond in the numerator. So we have started learning dimensional also. Ready for one more? Let's start with 20 gigameter. Convert 20 gigameter into picometer. We'll do dimensional. See how. What do you know? You know that 1 gigameter, this is a ratio I know. 1 gigameter, you can check here. Giga is here. This is giga. Is 10 raised to power 9 meter. And you also know that, now check here. Where is your pico? Pico is here. And you know that 1 picometer is 10 raised to power minus 12 meter. I will use these ratios. I know the relation between gigameter and meter. I know the relation between picometer and meter. So I'll convert my gigameter into meter by using this ratio. Then meter to picometer by using this ratio. This is called a dimensional. How? Let's see. Start with what is given to you. So what is given to us? 20 gigameter. Start with that. Convert this gigameter to meter using this ratio. What do you want? Meter. Take this meter in the numerator. Gigameter in the denominator. So that gigameter and gigameter cancelled and your answer is in meter. Don't do calculation. We'll do only final calculation. Now I'll convert my meter to picometer. For that, I'm going to use this ratio. What I want? Picometer. So plug in this ratio, picometer in the numerator and 10 raised to minus 12 meter in the denominator. Meter cancelled. Now My answer has only one unit, picometer, and that's what I wanted. Now I'm going to put all the numbers of the numerator together. These are the numbers in the numerator, and the denominator numbers are these. And the unit left is picometer. Rest of the units are cancelled. So what's the answer? When you do the mathematics, calculators are permitted in chemistry Olympiad examination as well as in AP examination. So you can use calculator. Otherwise, right now, no calculator is needed. This will become 10 raised to power 9 times 10 raised to power 12 picometer, which you can write 2.0 times 10 raised to power 22 picometer. That's the answer. So now it's very clear that we can convert one unit to another unit by using the well-defined ratios from these prefixes. These are defined prefixes. And with the help of this dimension analysis, the way I did here, plug in the ratio, cancel the units and get the answer. So this method is very useful in doing mathematical questions in chemistry. Now we have already started using dimensional analysis in which we are converting one unit into another unit from the defined relationships or defined ratios. So you are using the defined ratios or relationship to convert one unit to another unit. You have to plug in the ratio in such a manner that the unit which you don't want will be eliminated out or cancelled out, and the unit which you want, you have to put it in the numerator to retain it. So ready for one question? Now we are going to solve this question with the help of dimensional analysis. You can see these are the ratios given to you, the relationships or the ratios. And this is something with which we have to start. If you look at this mega, mega is a prefix which we were using in the metric system. And we know that 1 mega is a bigger unit, is 10 raised to power 6. So here I can say 1 mega bushel is, yes, is 10 raised to power 6 bushel. That I already know. This ratio is not given because they are expecting you to know the prefixes of the metric system. So let's start with what is given to us. What is given to me is 1.0 mega bushel. So from 1.0 mega bushel, where can I go? I can use this ratio and I can get bushels. And from bushels, I can use this ratio and I can get packs. And from packs, I can get quarts. So let's start with what is given to us. Now, to go from mega bushel to packs to quarts, I'm going to use all these relationships in the form of ratio. Okay, so let's start. 1.0 mega bushel, plug in the ratio. This one. What do you want? Bushel. So it should be in the numerator. 10 raised to power 6 bushel over 1 mega bushel. You can see mega bushel cancelled. You are left with bushel. Don't do any calculation because we will do calculation only for quarts in the last. Now, let's see packs. We know that 1 bushel is 4 packs. So I'm going to plug in this ratio. 4 packs over 1 bushel. Now you can see this bushel and bushel cancelled. We are left with packs. But I need the answer in quarts. So I'm going to plug in the next ratio. 8 quarts is 1 pack. So I'll put 8 quarts, quart in the numerator because that's the unit I want finally. Finally, I want quarts over 1 pack. Now pack and pack cancelled. Now check all the numbers in the numerator. 1.0, 10 raised to power 6, 4, 8 divided by. In the denominator, we have only 1. And the unit left is quart. Now you can solve it. Is 3.2. I'm placing it in scientific notation. 10 raised to power 7 quart. That's the answer. So this is one of the simplest example of dimensional. Let's do another example. Now read the question very carefully. How many milliseconds does it take for light signal from Earth to reach and return from a satellite that is 30 miles above the Earth? Mile is not a standard unit. Mile is like a common unit. It's not a well-defined unit. So that's why these kind of conversions, they will give you in the question paper. Only for the metric system, the prefixes, standard international units, and the metric system, their conversions will not be given to you. But these one, the common one, not very well defined, they will be given to us. So 1 mile is 1.6 kilometer. What are they asking? Time. What is given? Speed. So what do you know about speed? Speed is distance over time. Over time. The speed which is given to me is meter per second. So if I rearrange this equation, just rearrange the equation, I can say time is distance over speed. I can say that. Now I need distance in meter because speed has a unit of meter per second. So distance has to be in meters. But here it is given to us in 30 miles. So I have to convert miles into kilometer. So I know that 1 mile is 1.6 kilometer. And I also know that 1 kilometer is 1000 meter. This is from the metric system, the prefixes. So these two ratios I know. So I can convert the distance here by using the dimensional, which is 30 miles. 30 miles, plug in the ratio. Miles to kilometer, you will go from miles to kilometer and from kilometer to meter. And why I'm doing so? Because speed is given to me in meter per second. So that's why I have to do it. So how much is this? 30 miles. Then plug in the first ratio, 1.6 kilometer over 1 mile. Then plug in the second ratio, 10 raised to power 3 meter, 1000 is 1 kilometer. And solve it. So 30 times 1.6 is, so finally when you solve it, you can see mile and mile cancelled, kilometer and kilometer cancelled, and the answer is 4.8 times 10 raised to power 4 meter. So it means the signal of light has traveled this much distance from satellite to the earth. This much distance is traveled by the signal. But they're asking me to calculate time. Now I'm going to plug in here. Distance is 4.8 times 10 raised to power 4 meter. Speed is 3.0 times 10 raised to power 8 meter per second. So I can write it like this. 4.8 times, this is mathematics, and the second will go in the numerator like this. Now meter and meter cancelled. So I'm getting the time in seconds. But are they asking in seconds? No, they're asking in milliseconds. So what do I know? I know that 1 millisecond is 10 raised to power minus 3 seconds. So I'm going to plug in here this ratio. I want my unit milliseconds. So millisecond will be in the numerator divided by 10 raised to power minus 3 seconds. When you solve it, you will get the answer as 1.6 times 10 raised to power minus 1 milliseconds. Time calculated for light signal to travel from Earth to satellite is 1.6 times 10 raised to power minus 1 milliseconds. So my answer is not ending here because they're asking how much time, how many milliseconds does it take for light signal to travel from Earth to satellite and return also. So from Earth to satellite, and that satellite is 30 miles above the Earth. So it means if this is the Earth and this is the satellite, then the light signal going from Earth to satellite and back to the Earth. So the distance travel is 30 miles going up and 30 miles coming down. So the time taken will also be double of this. So the time needed for that signal to go from Earth to satellite and back to Earth will be 2 times 1.6 times 10 raised to power minus 1 milliseconds, which is 3.2 times 10 raised to power minus 1 milliseconds. So this is how we have to use dimensional analysis, conversions, prefixes, converting one unit to another unit in chemistry calculations.